Hello, and welcome to this video on parallel computing. I'm here to provide you with valuable insights. The voice you're hearing is AI generated, and this video is supported by the Norwegian Research Infrastructure Service. This involves collaboration between the universities of Bergen, Oslo, Tromsø, and NTNU, and working with Sigma 2 to manage the national e-infrastructure. In this video, we will provide more details on executing jobs on Fram. We will attempt to increase the matrix dimension to 65,536 and execute this matrix multiplication process as a parallel computation on the Fram Linux cluster using OpenMP. We will continue to apply the OpenMP on Fram directory located in the work folder on Fram. By using the ll command, we can view the contents of this directory. You've previously seen the Fortran program that utilizes OpenMP, but let's review it again. We will attempt to increase the matrix dimension to 65,536. Let's also modify the job script. In the job script, we will change the job name and the Slurm output file name. We use the sbatch command to submit the job script to the Slurm queue system. The job is given the number 5988061. Using the sq command, we can see that the job has already finished. This suggests that something went wrong, as the job should have had a much longer wall time. First, let's clear the terminal. The ll command shows that a new Slurm output file for a matrix dimension of 65,536 has been generated. We can examine the Slurm file using the Emacs editor. Remember to use the tab key for autocomplete while typing these long file names. Inside the Slurm file, we notice a segmentation fault occurred after the compilation finished. This is unexpected, as the only change made was updating the matrix dimension to 65,536. We will open the Fortran program and try to resolve this issue. We will try using allocatable matrices and allocate them at the start of the program. After making this change, we can resubmit the job script to the Slurm queue system. The job ID becomes 5988062. Checking with the sq command, we find that the job has already finished. This indicates that something is still not working, as the job should have had a much longer wall time. Let's first clear the terminal. The ll command reveals that a new Slurm output file for a matrix dimension of 65,536 has been created. We can open the Slurm file with the Emacs editor. Remember to use the tab key for autocomplete while typing these long file names. Inside, we see that the job was terminated due to being out of memory, OOM killed. It's not surprising that our job was terminated due to being out of memory, given that the normal compute nodes on the Fram Linux cluster have only 59 gigabytes of available memory. When we used a matrix dimension of 32,768, the memory usage was about 24 gigabytes. Therefore, increasing the dimension to 65,536 would result in a memory usage of approximately 100 gigabytes. Thus, we need to use the big mem compute nodes on the Fram Linux cluster. We will open the job script to address this issue. In the job script, we will use the partition option to request 32 CPU cores on the big mem nodes. We must also specify the memory usage, and we will request 110 gigabytes of memory. We submit the job script to the Slurm queue system using the sbatch command. The job is assigned number 5988063. Using the sq command, we see that the job has been running for 53 seconds on the big mem partition. Let's clear the terminal. Executing the sq command again shows that the job has been computing for more than 3 minutes. Using the command once more indicates that the job has finished. The ll command shows that a new Slurm file has been created. Let's clear the terminal again. the Slurm file can be opened with the Emacs editor. Remember to use the tab key for autocomplete while typing these long file names. Inside the Slurm file, we see that the execution time was about 525 seconds. Dividing this time by 8 gives approximately 66 seconds, which was the execution time for a matrix dimension of 32,768. This is expected because the matrix multiplication is performed by a triple nested loop, and doubling the matrix dimension results in an 8-fold increase in computation time. We can see that the CPU utilization was about 80%. With a matrix dimension of 32,768, we achieved a CPU utilization of about 85%. However, the elapsed time is approximately 644 seconds. The combined compiling and execution time was about 534 seconds, indicating an overhead of around 110 seconds on the big mem node. This reduced the CPU utilization to about 80%. The memory usage was approximately 97 gigabytes, so this job couldn't be executed on the normal compute nodes. Additional information about the job can be obtained using the cf command. The used CPU time is around 4 hours and 35 minutes, equating to about 4.6 CPU hours as noted in the Slurm file. The CPU efficiency is consistent with the Slurm file, and the core wall time is about 5 hours and 43 minutes. The core wall time corresponds to the wall time of about 10 minutes and 44 seconds multiplied by 32. Lastly, the job utilized about 88% of the requested 110 gigabytes of memory. The cef output can be appended to the Slurm file as before. To use the scripts and files from these videos as templates for your work, you may copy them from the Saga Linux cluster. First, move to the folder, cluster, work, support, parallel, computing, YouTube. Use the ls command to display its contents. You'll recognize many scripts and files from the videos. We can copy any of these files to the home folder. In our next video, we will explain how to schedule jobs on the Fram Linux cluster using the math kernel library, MKL. I am looking forward to the next video. Wishing you all happy computing in the meantime.